So today I'm going to discuss the main type of methodologies in the assessment of desirability in economic and environmental or social aspects in constructing a highway proposal. Once a transportation plan has been finalized and a demand along each of its highway link has been established, a process must be put in place that helps identify the best solution for each individual proposal within a highway network. Each project must therefore be subject to an appraisal. So the aim of highway appraisal process ay upang ma-determine yung economic, societal, and environmental feasibility ng isang proyekto under examination. Through this process, natutulungan yung mga highway planners na ma-determine whether a project ay desirable in absolute terms, and also it is a means of choosing between different project options na kung saan ang lahat ay may ability na ma-meet yung goals and objectives ng isang proyekto. So the appraisal process of the highway schemes ay nahati sa dalawang sections, the economic evaluations and the environmental assessment. Economic appraisal of highway schemes. In the development of highway project, the developer will require an economic assessment of the route options under consideration. This will require comparing the performance against the current situation termed do-nothing alternative and or against the do-minimum alternative, which involves the low cost upgrading of the existing facility. The benefit cost analysis is the most common economic evaluation method. Using this method, any proposal na mayroong positive net present value is said to be economically sustainable in absolute terms, na kung saan a competing project options are being compared, assuming they are both used in identical capacities over the same period. So in this case, the one with the numerically larger NPV is selected. Here are some main steps of cost-benefit analysis. So the first one is identifying the main project options. This is the fundamental step of CBA process where the decision maker compile a list of all relevant feasible options na nais nilang i-assess. Finding sound feasible options is an important component in a decision process. There are many procedures for both identifying and defining project options. These include drawing in the personal experience of the decision maker himself as well as the other expert in the highway engineering field, making comparisons between the current decision problem and the ones previously solved in a successful manner, and examining all relevant literature. The next one is identifying all relevant costs and benefits. The application of cost-benefit for project assessment in the highway area is made more complicated by the wide array of benefits, and many of those benefits of improvements of transport project equates to decreases in costs. The primary groupings that contains this type of economic gain is termed user benefits, and this grouping includes reduction in vehicle operating costs, savings in time, and reduction in the frequency of accidents. Reductions in vehicle operating costs. For a highway scheme, the new upgraded project leads to lower levels of congestion and higher speeds than on the existing roadway, usually resulting in lower fuel consumption and lower maintenance costs due to the reduced wear and tear on the vehicles. Savings in time. The upgrading of a highway installation will invariably reduce travel time as well as improving the reliability of transport services. It analyzes the value of time savings within the cost-benefit framework, focus on distinguishing between travel for work and travel for non-work purposes. Reduction in the frequency of accidents. In the case of a highway, this requires comparison of the accident rate on the existing unimproved highway with that of other highways elsewhere in the country constructed to the higher standard of the proposed new road. Normally, the higher the standard of construction of a highway, the lower its accident rate. The next one is economic life, residual value, and discount rate. A highway project is often complex and long-term, with the costs and benefits associated with it occurring over a long time frame, which we term the life of a project. Given that the transport development project has the potential na magtagal, it is impossible na mag-set ng life ng isang project with any degree of certainty. Truncating the analysis can be justified on the basis of the uncertainty with which costs and benefits that occur beyond a certain time horizon can be predicted. The difficulty in assigning a meaningful residual value to a project after so few years in commission results in the solution being rather unsatisfactory. It is far more advisable to extend the evaluation to a future point in time where the residual value is extremely small relative to its initial value. The costs and benefits occur at different times over this time horizon. Because of this, they cannot be directly combined until they are reduced to a common time frame using another parameter, the discount rate, which translate all costs and benefits to time equivalent values. Use of economic indicators to assess basic economic viability. Once the two parameters of project life and discount rate are set into place, this allow all costs and benefits to be directly compared at the same point of time. So yung decision maker ay pipili ng actual mechanism na gagamitan for analyzing and comparing the costs and benefits para ma-determine yung final answer para sa net benefits ng bawat project options under construction. So ilan sa techniques na maaaring gamitin ay mga sumusunod. Net present value. NPV is used in capital budgeting and investment planning to analyze the profitability of a projected investment or project. Internal rate of return. The IRR will give the rate at which the net present value for it equals 0. Benefit-cost ratio is an indicator showing the relationship between the relative costs and benefits of a proposed project expressed in monetary or qualitative terms. Advantages and disadvantages of cost-benefit analysis. It is really important to undertake a cost-benefit analysis before mag-start ang isang project kasi it is most suitable for ranking and evaluating different highway options rather than for testing an absolute suitability for a project. Kasi lahat ng valuations ng costs and benefits ay maaaring masubject sa error and uncertainty. Advantages of cost-benefit analysis. The use of the common unit of measurement, money, facilities comparisons between alternative highway proposals aids the decision-making process. It also offers a broader perspective than a narrow financial or investment appraisal, concentrating only on the effects of the project on the project developers, be that the government or a group of investors funding a toll scheme. Disadvantages of cost-benefit analysis. The primary basis for constructing a highway project may be a societal or environmental rather than economic one. If the decision is based solely on economic factors, however, an incorrect decision may result from the confusion of the original primary purpose of a proposed project with its secondary consequences. The method is more suitable for comparing highway proposal designed to meet a given transport objective rather than evaluating the absolute desirability of one project in isolation. Lastly, although some limited recognition may be given to the importance of costs and benefits that cannot be measured in monetary terms, say for example, the environmental consequences of the project in question, they tend to be neglected or at best downgraded within the main economic analysis.
Cost-benefit analysis is most suitable for ranking or evaluating different highway options. The advantages and disadvantages of cost-benefit analysis. First advantage is that the use of common unit of measurement, money, facilitates comparisons between alternative highway projects and hence aids the decision-making processes. Second is that given that the focus of method is on benefits and costs of the highway in question to the community as a whole, it offers a broader perspective than a narrow financial or investment appraisal concentrating only on the effects of the project on the project developers, be that the government or a group of investors funding a toll scheme. First disadvantage is that the primary basis for constructing a highway project may be a societal or environmental rather than an economic one. So this, for example, if the decision is based solely on economic factors, pwede tayo magkaroon ng mga incorrect decisions na yung ating primary purpose ng project proposal may result to the secondary consequences, which are measurable in money terms. Disadvantage is that the method is more suitable comparing highway proposal designed to meet a given transport objective rather than evaluating the absolute desirability of one project in isolation. Ang ating mga decision makers, mas ginagamit nila ito to use in ranking a number of alternative highway design options imbis na to assess the absolute desirability noong project proposal natin. Third disadvantage is that although mayroong mga limited recognition na binibigay dun sa mga importance ng cost and benefits na hindi na measure in monetary terms. Say for example, yung mga environmental consequences natin within the main economic analysis. Yung goods capable of measurement in monetary terms, sila yung mas pinagtutuunan ng pansin kaysa dun sa mga hindi nakaka-contribute dun sa mga nag-fund nitong project. This payback analysis is extremely simple procedure that is particularly useful in evaluating proposals such as privately funded highway projects where tolls will be imposed on users of the facility in order to recover construction costs. So once na may ginawa ang mga private sectors natin na projects on highways, kinakailangan at least maibalik yung funds na ginamit nila in constructing the said project. So this pumapasok iyong payback analysis before constructing the project. So, in evaluating the project proposal, the payback analysis, the following formula is derived. Okay, now this equation 2, let's assume that a zero discount value is being used, but this is not always the case. If it is assumed that the net cash flows will be identical from year to year, and that these cash flows will be discounted to present values using a I is not equal to 0, then the uniform series present worth factor, or the P/A, can be utilized within the following equation. So this equation number 3 is reduced to equation number 1, which exactly the same expression as given in equation 1. The environmental appraisal of highway schemes. In this environmental appraisal of highway schemes, dito pumapasok yung concern natin on environmental effects of the project. While yung ating cost-benefit framework for a highway project is nag-a-address lang ng twin objectives of transport efficiency and safety. Pero it makes no attempt to value its effects on the environment. So with this, nagkakaroon ng environmental assessment. Itong National Environmental Policy Act na ito is nag-prescribe ng format para dun sa ating EIS na nire-require doon sa developer na mai-assess yung kanilang project. So itong directive natin, they also included sa minimum details na kinakailangan na meron doon sa EIS na kanilang ginagawa. So kinakailangan ma-contain din yung full environmental impacts forming the assessment framework. So here are presented the impacts on the appraisal grouping. So the new approach to appraisal, or what we call NATA. Within this NATA, kinakailangan lahat ng significant impacts ay ating mini-measure. The following table presents the framework for appraisal summary. So here, it contains the criterion, which are the objectives I stated earlier, such as the environment, the safety, the economy. So let us now proceed in topic number 2, the basic elements of highway traffic analysis. So dito, mini-measure natin yung functional effectiveness ng highway with its ability to assist and accommodate the flow of vehicles with both safety and efficiency. The speed-density relationship. So, dito pumapasok na kung saan kapag ang isang vehicle is nagta-travel along a stretch ng isang kalsada ng mag-isa, yung density nito is most likely at near zero. And yung speed nito at which the car can be driven is determined solely by the geometric design of the road. Kapag mas maraming vehicles ang gumamit nung kalsadang iyon or nung highway, mas tataas ang density nito at bababa naman yung speed. So, thus, the limiting values of the relationship between speed and density are as follows. So, when k or the density is equal to 0, the speed is equal to the free flow value. And when u or the speed is equal to 0, the k or density is equal to what we call jam density. This is a linear illustration of speed-density relationship. So Green Shields of 1934 defined a linear relationship between speed and density, in which he expressed it as u is equal to c1 plus c2 times k, where c1 and c2 are constants. So, meron ding ibang researchers, si Pipes and Greenberg, na nag-observe ng nonlinear behavior at each extreme of the speed-density relationship. Unlike sa mga nauna na linear siya. So, the equation is the u is equal to c1 raised to negative c2 times k. So, using this equation, the boundary conditions are, first is when the density is equals to 0, the free flow speed is equals to c1. And when speed is equal to 0, jump density equals infinity. Okay. So this flow density relationship, it is under the topic I have just discussed. So combining the equations given a while ago, we get Q is equal to the free flow value times K, or the density, minus K squared over the jump density. Now, in order to establish the density at which the maximum flow occurs, it is differentiated and set equal to 0 as follows. Since itong ating free flow value is not equal to 0, the term within the brackets must equal to 0. Therefore, the given equation is derived. Next is the speed-flow relationship, in which dito, as the derivation, in order to derive this relationship, ina-arrange natin yung nauna equation, which itong K is equal to the jump density times L minus U over the free flow value. So, by combining this formula with equation, Q is equal to the jump density times U minus U squared over the free flow value. So, yun na yung na-derive. So, itong relationship na ito is also a parabolic relationship. This illustration shows the speed flow relationship. Ayan. So, dq over dt is equal to the jump density times L minus 2u over the free flow value is equal to 0. Since yung ating jump density is not equal to 0, the term within the brackets must equal to 0, as I said earlier. So therefore, L minus 2u with the subscript m over the free flow value is equal to 0. Thus, we derived um is equal to uf over 2. So, yung natin is the speed flow at the speed at maximum flow. So, is thus equal to half the free flow speed, uf. Its location is shown in the illustration. Okay. So, yeah. So, combining the equations, Qm is equal to um times Km is equal to uf over 2 times Kj over 2. Therefore, we get an equation of Qm is equal to uf times Kj over 4. So yun na yung final equation natin.
The level of service approach. A level of service describes in a qualitative way the operational conditions for traffic from the viewpoint of the road user. It measures in terms of variables such as travel time and traffic speed. 6 levels of services according to Highway Capacity Manual ranging A as best to F as worst. So service A, na-indicate lang niya yung traffic flow is equals to 0. Service B naman ay yung reasonable free flow conditions. Yung service C naman ay yung stable flow conditions. Yung service D naman ay yung high density levels but stable height still prevails. Service E naman ay yung capacity of highway ay na-reach na. Yung service F naman ay yung state of breakdown. Doon nagsisimula yung heavy traffic. So in some definition, to determine routes levels of service, dapat may knowledge tayo about the relationship between hourly volume, peak hour factor, and service flow. So, yung formula natin sa PHF is equals to B is divided by 15 times 4. Ay yun yung pagkuha natin ng peak hour factor. Yung peak hour factor is the ratio of the hourly volume to peak 15 minute flow. Yung B15 natin enlarged to hourly volume. Tapos yung P naman natin ay yung the highest hourly volume within 24 hour. May isa pa tayong formula na SF equals to V15 times 4. Yung SF natin ay natawag natin service flow within the peak 15 minutes flow o B15 enlarged to an hourly volume or the number of vehicles per hour. Maximum service flow rates for multi-lane highways. Katulad ng lahat ng garage may standard width tayo na 3.65. Before that, may mga conditions tayo. Una, yung ideal conditions para ma-compute natin yung maximum service flow o SF. Ito yung formula natin na SF max equals to CJ times BC times N. Yung N natin is the number of lanes in each direction and CJ is the capacity of standard highway lane for given design speed J. Bago yung BC natin is the maximum ratio of flow against different level. Ito yung mga standard value natin. Ito yung sa CJ na volume per hour. Tapos ito yung level of service natin, yung VC. And for non-ideal conditions naman ay may formula naman tayo na SF equals CJ times VC times N times F sub W times F sub HV times F times V times FE. Yung FW natin natawag natin adjustment factor. Yung FHV naman ay natawag natin heavy vehicles kung saan dito ma-determine natin kung trucks or bus or RV. Yung FP naman natin ay yung driver's classification. Either say commuters or classes of drivers, other classes of drivers. Yung FE naman natin is the highway classification. Dito natin na-determine kung siya ay galing sa urban, suburban, o rural. Yung VC natin ay maximum ratio in different level. Bago yung N naman natin ay number of lanes in each direction. Bago CJ natin is design speed in kilometer per hour. Ito yung standard value natin na variable dun sa multi-lane. Ito yung adjustment factor natin. Ito yung correction factor natin. At ito naman yung driver classification o yung FP natin at yung highway classification natin. Rural o urban. Nabanggit kanina yung FHB. Bago magkuha yun, dapat may formula. FHB is equals to 1 over 1 plus quantity PT times quantity ET minus 1 plus PB quantity EB minus 1 plus PR quantity ER minus 1. Yun lang. Yung PT natin ay yung percentage of trucks in traffic stream. Yung PB natin is percentage of buses in traffic stream. Tapos yung PR natin naman ay yung percentage of recreational vehicles in traffic stream. may nabanggit kanina, ET, EB, at ER, ayun naman ay yung mga PCA for trucks, buses, and recreational vehicles. Lumako naman tayo sa maximum service flow range for 2-lane highway. Under sa ideal conditions, yung 2-lane highway ay meron daw 28 passenger car units per hour. So ito yung magiging formula natin sa service factor divide 28 times BC. Yung 28 na yun ay magiging constant natin. Ay, alam naman natin yung BC ay yung maximum ratio of flow rates in different levels. So sa ideal conditions, dapat ma-achieve niya ito yung mga conditions na to. Yung passing na permission throughout 100% of section highway in question. Yung lane width dapat niya ay at least 12 feet o 3.65 meter. Yung clearance hard shoulder niya dapat ay at least 6 feet o 1.83 meter. Yung design speed ay at least 6 miles per hour o 96 km per hour. Yung traffic stream dapat niya ay mag-compose ng mga private cars. Yung flow ng direction niya dapat ay balance 50-50. May level of terrain. Tapos yung walang obstruction to flow caused by vehicle turning movements, traffic specifications. Sa non-ideal naman, may highway capacity na reduced from 28 PCU per hour. So ito magiging formula natin. Yung service factor divide 28 na constant value times BC times FD times FW times FD. So yung FD natin ay yung tatawag nating unequal distribution of traffic between two directions of flow. Bago FHB naman ay yung heavy vehicles na kung ma-determine natin kung truck, bus, or RV. Yung BC naman natin ay yung maximum ratio of flow against different level. Tapos yung FW naman natin ay yung adjustment factor. So may standard value tayo katulad ng sa level of service, yung service A hanggang F. Tapos yung correction factor natin. Tapos yung clearance natin. Yung vehicle type o type of terrain, kung truck ba siya o buses or RV. Bago yung BC ratio natin in different level. Lumako naman tayo sa sizing of producing the highway capacity manual approach. So when you sizing a new roadway, a desired level of service is chosen by designer. This value is then used in a design traffic volume in order to select an appropriate cross-section for the highway. So in order to derive this value for a highway, the annual average daily traffic or natawag nating ADDT for a traffic highway is multiplied by a term called the K factor such that yung DHV natin na natawag natin design hourly volume is equals to K na K factor times AADT. Kung saan yung K ay nagka-correspond sa highest annual hourly volume. May two values tayo ng KI. Yung una ay K1 kung saan yung value is nagka-correspond sa hourly volume na 0.15. Sa K30 naman ay yung value na nagka-correspond sa 13 highest hourly volume is equals to 0.12. Since alam naman natin na yung DHB is a directional flow as is AADT, yung flow natin ng peak direction ay magiging DDHB kung saan ito yung magiging bagong formula natin na na-estimate by multiplying the directional factor D. Ito panibagong formula kung saan yung DDHB as equals to K, yung highest annual hourly volume times D, yung directional factor at yung times AADT na makukuha natin sa una. So, yung mga simple problems natin is hindi na nasama kasi yun siya naman ay direct substitution. Kaya Yung mga sample problem natin is hindi natin makukompute.